Guys, now please confirm to me. All of you get my voice on screen. Those who are attending in online, am I audible, guys? Guys, now please confirm to me. All of you get my voice on screen. Those who are attending in online, am I audible? Yeah, nice. Voice on screen, both are clear to all of you guys. Now please confirm to me. Right. Good morning, guys. Right, sir. Now just give a minute of time. I'll start it. Right, sir. Now check it. What is the topic here? We are understanding here. Nothing. Concepts are like what there. C and C++ are platform dependent programming languages, but Java is a platform independent programming language. The topic here we have to understand. Okay. Right, sir. Now before that, what is the point here we are understanding there? We have already discussed some topics like what there. What topics here we understand. Observe carefully. Few points here I'm going to discuss there. Previous concepts now. Java history is one of the concepts we completed already. Next one is differences between Java and others, where the very first difference we started with what there. C and C++ are static programming languages, but Java is what? A dynamic programming language. Simple. Reasons are very clear. In a C and C++, static memory allocation is going on. In Java, dynamic memory allocation is going on. What is static memory allocation? If the memory is allocated for the data at what time? Compilation time. Then that memory allocation is static memory allocation. If the memory is allocated at runtime, then that memory allocation is what there? Dynamic memory allocation. So Java is following dynamic memory allocation. So Java is what there? Dynamic programming language. C and C++ are following static memory allocation. So that's what C and C++ are what their static programming languages that we understood clearly. So next one is after that, after completion of this point here, preprocessor is required in C, C++, but preprocessor doesn't required in Java. Answer is very clear. So what is the location of the preprocessor first? The location of the preprocessor. Alright, sir. Now, preprocessor is the first phase in the compilation. Preprocessor is what there is the first phase in the compilation. Understand it clearly. In a C and C++ programming, the complete predefined library was provided in the form of header files. To include the header files, we will use hash include statement. Understand my point clearly now. Hash include statement here we have to use. If we compile a C program, Preprocessor will recognize hash include statements. Preprocessor will take the header files names. Preprocessor will check whether these header files are available or not in C, C++ softwares. If these header files are available in a C, C++ softwares, if these header files are available in a C, C++ softwares, then immediately what is going to be happen there? Preprocessor will load the data files content to the memory. If these header files are not available in C, C++ software, preprocessor will raise an error. Simple point. That is completed. After that, after completion of this, coming to the conclusion now, in a C and a C++, preprocessor is required. Why? Because to recognize hash include statement to load header files content to the memory, what is required here? Preprocessor is required. But in Java, preprocessor is not required. And before this Java and its preprocessor is not required, understand the diagram where is the location of the preprocessor. See compilation.exe, execution and output. In the compilation, what we are having there? Preprocessor. Right, it's the first phase in the compilation. Leave it. In Java, how preprocessor is not available. Alright, the point here we have to understand. In Java, the complete predefined library was provided in the form of header files or in the form of classes and interfaces in packages. Examples for these packages are what there? Java.io, Java.util, Java.sql, like this. So many packages are available. Right, sir. Now, if you want to include this predefined library, if you want to include this predefined library in Java applications, then we have to import the packages. Import statements are provided. What is that import statement now? Import java.io.star, import java.sql.star, import java.util.star. Like this here we are having import statements. Good. If we compile Java file, then a compiler will perform some actions. What actions that compiler is able to perform? The compiler will recognize all the import statements. Compiler will identify, that means will take the provided package names. Compiler will check whether these packages are available or not in Java software. If these packages are not available, compiler will raise an error. If these packages are available in Java software, immediately compiler will not raise any error. At the same time, compiler will not load any package content to the memory. Compiler is not responsible for loading packages to the memory. Okay, in Java, if compiler is not responsible for loading libraries to the memory, then who is responsible for loading that in the memory? Right, JVM is responsible for loading that packages contented to the memory at runtime. Loading predefined library at compilation time is called as static loading. Loading predefined library at runtime is called as what there? Dynamic loading. Understand it clearly. Now coming to the conclusion, in Java preprocessor is not required. Why? Because in Java hash include statements and header files are not available. Because of that reason, no question about like what their preprocessor. Alternatively, what system is available? What we have there inside the Java, right? Classes and interfaces in packages and import statements are available. To recognize these import statements, to include these import statements, what is already available there? What we have there now? Compile and JVM already we are having. So no need to use what their preprocessor. That's already we understood that. Java related diagram are given there. Java file compilation dot class files. Please remember it. After compilation of the Java, then what files here we are getting there? Dot class file, execution and output. Now here what we are getting there? Preprocessor, compiler, assembler, loader, link editor. But I crossed it, that I strike it off it. Why? Because it is not available in Java. Again, compiler internal structure, almost all 6 pages are available. Lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, and code generation. All of you understand it clearly. Then what next one here? We provided here. Now we have to understand the points. No, right, sir. What are the differences between hash include statement and import statement? All right, where almost all 4 to 5 differences here are given. Now try to understand it. No. Hash include statements exist in C and C++. Import statements exist in what there? Java. Hash include statements are used to include the predefined libraries which exist in the form of what their header files. Import statements are used to include the predefined libraries which exist in the form of like what their classes and interfaces in what their packages. Hash includes. अरे यार Again, the problem is coming. Just 1 minute. Hash include statements are having, right, sir. Now, hash include statements, yeah, hash include statements are evaluated by the preprocessor. Import statements are evaluated by both the compiler and what next one you know, JVM, right, sir. Hash include statement support static loading. Import statement support only what the dynamic loading. In a C and C++ programs to include more than one header file, we have to use more than one hash include statements. But in Java, to include more than one class or interface of the same package, no, just it is a sufficient to take only one import statement with what notation can no star notation. Right now, these are the points we understood up to now. Now, the third difference today here we have to start. What is the third difference here we have to understand? C and C++ are platform dependent programming languages, but Java is a platform independent programming language. That's the next one. C and C++ are what they're platform dependent programming languages, but Java is what they're a platform independent programming language. Clear? Right, sir? Now, don't worry. 1 minute. Right, sir. Now the point is what? Before going to start, C, C++ and Java, platform dependent or platform independent. Before that, first of all, tell me when a programming language is platform dependent programming language and when a programming language is platform independent programming language, that we have to understand. Very clear. No confusion, nothing else. Straightforward information. Now the point is what? If any programming language allows its applications to perform compilation and execution both on the same operating system, not on two different operating systems, on the same operating system, both the compilation and execution both must be performed on the same operating system, not on two different operating systems. That programming language is called platform dependent programming languages. That's it. All of you understand it clearly? If any programming language, if any programming language allows, if any programming language allows its applications to perform compilation and execution on the same operating system, not on the different operating systems, not possible on two different operating systems, then that programming language is called a platform dependent programming language. The programming language is called what there? A platform dependent programming language. Right, sir. Now, this is the meaning of like what there? Platform dependent programming language. Examples. Directly I'm telling to you C and C++. How C and C++ are platform dependent programming languages that we have to understand. Let me show some diagrammatic representation. All of you observe carefully. All right, sir. Right. Now understand it clearly. All of you know. For example, I want to take this is my C program. First of all, I want to prepare the diagram as per the definitions. Understand it clearly. Dot C file. That's it. What file is available here? Dot C file. Okay, fine. Then what next one here? After this, we have to perform compilation. There, I have to take compilation. Compilation. We know already when we compile a C program, there we are able to get dot exe files. When we perform compilation, there we are able to get what files there? Dot exe files. There's a confusion in the case of C programming language. After the compilation, what we are getting is that .exe file, .obj file, .ai file. It's a problem actually. This is a confusion in the case of like what there, C programming language, C and C++. But in Java, no confusion. Before compilation, .java file. After compilation, .class. That's it. No other files are going to be generated in the case of Java. .java, .class. That's it. Right, sir. Now here we are getting some .exe file. It's okay. When we completed this .exe file, then what next one here we are getting there? Then we have to submit this program for execution. So now here we have to provide like what there? Execution. There we have to provide like what there? Execution. Now understand it clearly. Execution. When we have execution process for it, there here we are able to get like what there? We are able to get some outputs. There we are able to get like what there? Some outputs. This is the total structure. Here we have to understand output. Fine. Next one is after this, after completion of this. Now I want to select some operating systems. This is compilation and this is execution. So two operating systems here I have taken. For compilation, one operating system. For execution, I have taken what there? Another operating system here I have taken. Nice. Now understand the point now. That's it. Understand the point here. For compilation, for example, I'm going to use Windows operating system. For compilation, I'm going to use what there? Windows operating system. Observe carefully. For execution, if you want to see, C is a platform dependent programming language. For execution also, we have to use what there? The same Windows operating system. Yes, sir. For the execution, we are going to use what there? Same Windows operating system. So now observe carefully, compilation and execution both are going on the same operating system. Then we can conclude that C and C++ are platform dependent programming languages if it is a case. But for our discussion point of what I want to use there, just for 5 minutes of time, I'm going to use some other operating system. I'm going to use some other operating system, Linux operating system, for what their execution purpose. What operating system here I'm using there? Linux operating system for what purpose there? Execution. Understand it clearly. What happened? Why it is going on like this? Let it complete it. Start this one also. ఈ ప్రాజెక్ట్ స్టార్ట్. ఇది okay. Now it is taking rest, I think so. Okay, right. Now understand it. No. So for few minutes of time, just let us understand it. What we have taken there, execution here we have taken, right? For execution, Linux operating system here we have taken. For a compilation, Windows operating system. For execution, what we have taken there, Linux now. Right. Now understand the point clearly. Observe carefully. When we compile C program on Windows operating system, when we compile C program on Windows operating system, there we are getting like what there .exe file here we are getting. Am I right? What we are getting there .exe file here we are getting. Okay. Whenever we are getting .exe file, there we are able to have the .exe file like what there zeros and ones here we are getting. There is the .exe file. What data here we are getting there? Now zeros and ones. Understand it clearly. All right. What is this .exe file actually? What we are getting the information here now? If we understand this .exe file data, what exactly this one? We can understand it clearly. .exe file, .exe file contains .exe file contains what is it? This one? This one? Yeah, it's coming actually. Yeah, you are expecting right? Mm. This one also full screen, no? It will not come. Mm. It's okay. Projectors. Okay, then I'll find the solution. Don't worry for it. Just 2 minutes of time. Then it is. Resolutions are not matched. Maybe. Yeah, I'll check it. Don't worry. The last 3 to 4 days max onwards, the problem is going on. Then it is. Nice. Just give a minute of it. Guys, now please check it. All of you get my voice on screen. Those who are attending in online, am I audible, guys? Is my voice on screen is clear to all of you guys? Those who are attending in online, please confirm to me. All of you get my voice on screen. Those who are attending in online, not clear. Just 1 minute. Now check it, guys. All of you get my voice on screen now. Is my voice is clear to all of you guys? Now please confirm to me. Is clear? Now it is clear, right? Now it's clear, right? Fine. Close up. Right. Sir. It's okay. Now it was stopped actually in my system. Yeah. Now. So we need to go for the diagram kit. Now try to understand it now. So what we are discussing there, actually, we are discussing about the platform independent programming languages. Okay. Now the point is like what there. Let me take a C program. Okay, fine. Say for example, this is my C program here. If you want to say it is a C program, then here we need to provide like what there dot C. Extension is like what there dot C that we can understand. Okay. Now I want to perform like what there compilation here. So to perform compilation here, okay. Now I'm going to take this now here. This is about like what their compilation. Right. After this compilation, then what next one here we are getting there? Right. We are able to get another file here. What file here we are able to get now? .exe file here we are getting .exe file. Now whenever we are getting this .exe file that we have to execute. Okay. Now I want to execute this program. To execute this program here, we have to go for execution process. Right. Now let me take this execution process here. Execution process. When we execute the program, automatically here we are able to get output here. Directly here we are able to get output like what there? Like this here we are getting some output. Okay, fine. For compilation, I'm going to use what there? One operating system. For execution also, I'm going to use what there? Another operating system. For compilation, I'm going to use Windows operating system, but for execution purpose, for our discussion point of view, I'm going to use what the Linux operating system. Up to this we prepared already. Now let's understand it clearly. When we compile C program on Windows operating system, when we perform compilation, then that is when we perform compilation over the C program, automatically here we are getting .exe file. Inside the .exe file, what data here we are able to get there? Just we are able to have zeros and ones. This is like what there, some code here. Now try to understand it clearly. The code what we provided here now. It's okay, fine. Now I want to give clarity on this point here. What exactly the code here we are able to get inside this .exe file. Observe carefully. .exe file .exe file contains directly executable code. .exe file contains what there? Directly executable code. It contains it contains the local operating system representations. It contains the local operating system representations. Understand my point here? Like Windows. That means where we compile our C program, that Windows operating system representations are available. And one more point here I'm telling to you, observe carefully. From one operating system to another operating system, internal data representations are varied. Each and every operating system is having its own data representation internally. Windows is having one type of representation, Linux is having another type of representation, and some other Solaris is having another type of representation. Understand my point here? Small difference I'm telling to you now. In the case of Windows operating system, maybe integer may take 4 bytes of memory or 2 bytes of memory. In MacBook, it may take like what there some other type of memory. Understand it clearly. So that depends on the operating system. In Windows operating system, we used to say folder, but in MacBook, we are able to say like what there some directory. In some other, maybe we are able to say like what there a folder or maybe some other terminology. So in some operating system, forward slashes are working. In some other operating system, backward slashes are working. So definitely operating system to operating system differences are available. Internal data representation is also bit different from one operating system to another operating system. Got it or not? Okay, fine. Now observe carefully. .exe file contains directly executable code. It contains the local operating system representations like what there Windows. So it has Windows representations. Windows represented .exe file. Now understand it clearly. What about our execution process here? Execution is going on which operating system now? Linux operating system. Execution is going on which operating system? Linux operating system. Now observe carefully. All of you understand it clearly. Execution is going on in Linux operating system. Okay. Now the point is what? Now who is performing actually this execution now? C engine is performing the execution. We already aware about it. Who is that machine here? No, C engine is one of the machine which is performing that execution actually. Observe carefully. C engine is performing that execution process. Right. Now the situation is what there? C engine is able to execute, C engine is able to execute Linux representations only. C engine is able to execute only what representations? No, Linux representations only. Why, sir? Now tell me why it is only executing Linux representations? No, why? Because it is available on the base of what operating system? No, it is available on the base of what operating system? Linux operating system. So it is able to understand only Linux representations. Now see the situation now. Here .exe file is as per which representations? Windows. .exe file is provided as per what there? Windows. But C engine is able to execute only what representations? No, Linux. If you provide Windows representations to Linux operating system, is it possible to run Windows representations on Linux operating system? Windows is having separate representations. Linux is having what there? Some other representation. Is it possible to execute Windows representations on Linux operating system? No, not at all possible. So because of that reason, because of this particular reason here, that C program required same operating system where we compiled for execution. For compilation and execution, we need what there? Same operating system. In the case of what there? In the case of C and C++. Because of this reason, might be because of this particular reason, there we can conclude that C and C++ are what there? Platform dependent programming languages. Right, sir. Now just I'm going to give copy of this in our document. Now try to understand it clearly. I'll give clarity on it. I'll give some text or data also. Now try to understand it clearly. Right, sir. Now just 1 minute of time. Let me complete this document here. If we compile C and C++ programs, if we compile C and C++ programs on Windows operating systems, then the compiler will generate a .exe file that contains directly executable code, and it contains the local operating system representations, and it contains the local operating system representations directly. It contains the local operating systems like what there? Windows representations. Good. Now the point is what there? Now understand the point clearly. Now the point is what? If you want to execute the Windows representate.exe file, we need the same Windows. We need the same Windows represent the same Windows operating system at a runtime. Right, so the same Windows operating system we required at what time here? No, at a runtime. No other operating systems are provided. Right, so now if you want to execute the Windows represented.exe file, we need the same Windows operating system at a runtime. All of you are getting it clearly, no? Alright, sir. Good. Right, sir. Due to this dependency, on the operating systems, C and C++ are right, sir. Now C and C++ are the platform dependent programming languages. Right, sir. Are you getting clarity on it? Why C and C++ are platform dependent programming languages? No, this is clear-cut analysis here. We have to understand only one point. So when we compile C program on Windows, no, Windows represented.exe file we are getting. If you want to execute that Windows represented.exe file, we must provide what operating system here? The same Windows operating system here we have to provide. Now see this diagram here. In the diagram, I'm going to change it now. Now here, now see this one. Because of this reason here, I have to remove this here. Now in place of this, then what we have to provide there? The same Windows operating system here we have to provide. Okay, here we have to provide the same Windows operating system. Right. Then only it is valid. Then after that, now I can remove this part here. Now Linux, in place of this Linux, I can provide like what there? Windows operating system here we are going to provide. Right, so now here we have to provide like what there? Windows operating systems. Now, okay, fine. Now this is the right diagram that we have to understand. 1 minute. Right, sir. It's okay. Yeah, that's okay, fine. So this is completed. How C and C++ are platform dependent? It's clear. Can I move forward? Next one is how Java is a platform independent programming language. How Java is a platform independent programming language, that we have to understand clearly. Right. So let us move on to the next point here. Platform independent programming languages content. I'll give clarity. First of all, what is platform independent programming language? The quite opposite of platform dependent. Already we have seen the definition here now. In the case of platform dependency, both the compilation and execution must use the same operating system. That's the point here. But in the case of platform independent, we can use different operating systems for compilation and for execution. Now the point is what there? If any programming language, if any programming language, if any programming language allows its applications to perform compilation on one operating system and execution is on the another operating system, then that programming language is called a platform independent programming language. The programming language is what? The platform independent programming language. Understand it clearly now. Right, sir. Example for platform independent programming languages are what there? We can say Java, of course, Python, of course, .NET. All are platform independent programming languages only. But anyway, our context is what there? Java. That's why I want to do some discussion over what there? Java programming language. But here the question is, how Java is a platform independent programming language? How Java is a platform independent programming language? That point here we have to understand. Now, understand the point clearly. How Java is a platform independent programming language. All of you observe carefully. No? Right, sir. Now, see this one. A simple content here I'm telling to you. Simple diagram here I'm going to provide here. Observe carefully. Then, first of all, here I'm going to take like what there a Java program. This is my Java program. Dot Java. Dot Java file. When Java program is available, there I want to perform like what there compilation. So I need to go for like what their compilation. So this is about like what their compilation. That's it. Now see this compilation. Now as per the definition, I'm preparing this diagram, put more concentration. No? Alright, so now when we perform compilation in Java, we are able to get a separate file. What separate file here we are able to get there? We can understand it now. Dot class files here we are able to get. Directly here we are able to get what there dot class files. Okay, what it contains we'll discuss later on. No need to worry for it. But first of all, here we have to understand it. Now, directly here, what we are going to provide. Now, observe carefully. Now, I'm going to perform multiple executions over the same dot class file. As per the definition only, I'm not deviating the definition. Understand it. Now, here, one execution here I'm going to perform here. One execution, and here we are able to get some outputs. Okay. This is like what I'm telling to you. Execution here, output values here we are able to get. Now at the same time, now okay, we can understand it. For compilation, one operating system, and for execution purpose, one operating system here we have to use. This is what we have to use there. For multiple executions here, we are going to use this. Okay. Right. So now, but mother execution scale we are going to provide. Later I'll confirm the operating systems what we are providing. So this now I'm going to confirm the operating systems what you are getting there. Now observe carefully. First of all, I'm going to take the operating systems like what there. Here I want to take Windows operating system. Okay. Now here I'm going to take like what there Linux operating system. Linux operating system here I'm able to take. Next one is here I'm going to take like what there. Alright, now solar is operating system I'm going to take. Sun solar is. Now here I'm going to take Mac operating system here we are going to take. It's okay. Similarly, now here we are going to take what there. For our understanding purpose, again I am going to take the same Windows operating system. Same. For compilation we have taken Windows. For execution also I have taken Windows. In the case of platform independent programming language, still I can show some difference. What difference here we are able to see? We are going to understand it clearly. Alright, sir. Now, understand the content here. All of you observe carefully. This is .java compilation on Windows. Class file here we are getting there. Multiple executions here we are providing on different operating systems. If it is done, if it is going on well, then definitely Java is what their platform independent programming language. Mr. Gardner. But now the point is what? How Java is a platform independent programming language. How is it possible in the case of Java like this? I'll give some clarity, understand it, no? When we compile Java program on Windows operating system, there we are getting a .class files. There we are getting what are the .class files. Inside the .class files, here we are having some code. Okay, here we are having what there some code. What code is available inside the .class file? I'll give clarity. Observe carefully. Now, what code is available inside the .class file? No, observe carefully. What I'm telling to you. .class file contains bytecode. That .class file contains what there bytecode. Listen carefully. In the future, I will ask one important interview question. What exactly the difference between .exe file, .class file? Two things I will discuss with you now. Then that will be one of the interview question. So that's why put more concentration. .exe file contains directly executable code, but .class file contains bytecode. Okay, what is the nature of the bytecode? It is not directly executable code. It is not directly executable code. Okay. It is not directly executable code. If it is not directly executable code, then what it is actually? Now, it is an intermediate code. It is an intermediate code, not a source code, not a executable code. In the middle, it is an intermediate code. Okay, and it has some specific nature, and and it does not include any operating system. This is important. It doesn't include any operating system representations, any operating system representations including Windows. Why I'm stressing on this Windows now? Now tell me, here we are doing work on what there Windows operating system. So what is the point I am telling there? Data class file contains bytecode. It is not directly executable code. It is an intermediate code and it doesn't include any operating system. It doesn't include any operating system representations, including what there? Windows operating system representations. This is the exact nature of like what there? Bytecode. .exe file is different, bytecode is different. Now try to understand it clearly. .exe file contains directly executable code, but it is what the intermediate code. Bytecode is not directly executable code. It is an intermediate code. At the same time, it doesn't have any operating system representations. Yes, sir. Got it or not? Okay, fine. Now observe carefully. What's the point here I'm telling there now? Okay, a neutral bytecode is available, but the condition is what? If you want to execute this neutral bytecode on Linux operating system, this bytecode must have Linux representations. If you want to execute this bytecode on Solaris operating system, that bytecode must have Solaris representations. If you want to execute this bytecode on MacBook, it must have Mac representations. If you want to have this bytecode on Windows operating system, it must have Windows representations. Understand my point, Kirno? So compilation is generating some code, but that code is not sufficient to run on any of the other operating systems. That code, that bytecode must have the local operating system representations where we want to execute the program. Sir, got it or not? Again, I'm telling there. Understand that with a small, minute difference, I'm taking the platform independent programming language. Your concentration is very, very important. In the case of C and C++, what I have done when .exe file is available, directly executed by providing the same operating system. But the situation is different. So why? Because dot class file contains bytecode. It is not directly executable code. It is an intermediate code, and it doesn't include any operating system representations, including what there Windows. But the point is what? But the condition is what? If you want to run this bytecode on Linux, no, that bytecode must have Linux representations. If you want to run it on Solaris, no, it must have Solaris. Similarly, Mac representation. Similarly, Windows representation. Understand the magic, no? Compilation is going on Windows, and again, if you want to execute that code directly on Windows, no, still it is not possible. Why it is not possible? Why? Because dot class file contains what there? Intermediate representation, not directly executable code. Okay, fine. Now, but my requirement is what there? I want to execute this bytecode on all these operating systems. Then only Java is what there? Platform independent programming language. When it is possible to execute that dot class file in all the operating systems, then only my Java is what there? Platform independent. Damn sure it is possible, but here the question is how is it possible? Right. I'll give some clarity, understand it now. To make exactly in this particular situation, to make Java program to execute under all the operating systems and to make Java programming language as a platform independent programming language, Sun Microsystems, or that company, Sun Microsystems, has given a set of converters. Sun Microsystems has given a set of converters, or we can call it as a translators, whatever it may be. Sun Microsystems has given a set of converters, translators. This was not provided by C programming language. This was provided by Java programming language only. A set of converters are provided by Sun Microsystems. Where the set of converters here we are going to use there. Now observe carefully. Here we are going to provide what there? A set of converters. Understand this clearly? Now here we required a set of converter. Right. Sir. Now we required again a converter. Now similarly again a set of converter here we required. Like this set of converters here we are going to provide. Now let me provide the data here. Just I want to say like what their conversion. Just simple conversion here I'm going to say. Now here also be I'm going to provide like what their converter or conversion. Both are same. Okay, fine. Right, sir. Now what is the job of these converters? Sir, now tell me. What is the job of these converters? Converters here are given there. That's nice. What is the job of the converter? No, this converter here I'm talking with you. Try to understand it first of all. What is the job of this particular converter here? This converter will take dot class file neutral bytecode as an input. Then it will convert that neutral bytecode into Linux bytecode, Linux based bytecode. I get my point here. Initially, that which bytecode is available? Neutral bytecode, no operating system representations. This converter will take that neutral bytecode and it will convert that neutral bytecode into local operating system represented bytecode. That Linux bytecode is called, that Linux bytecode is called native code. That Linux bytecode is called as what there? Native code. Understand it clearly now. Native code. Okay. NC I'm providing there for the sake of your understanding. Native code. Understand it clearly. Okay. When this native code is generated by this converter, we can execute that Linux code on Linux operating system and we are able to get outputs. Clear. My equation is clear now. Okay, right, sir. Now similarly, this converter, what is the purpose of this converter now? It will take this neutral bytecode as an input and it will convert that neutral bytecode into like what code here now? Right, native code. Native code in the sense what there? Solaris representations. Solaris representations are converted here. That Solaris represented code will be given to execution process. Now the execution process will execute it and it is able to generate some outputs. Similarly, this converter will take this neutral code as an input and it will convert that neutral bytecode into MAC representations, MAC bytecode. When MAC bytecode is generated, if you give that MAC bytecode to the execution process now, automatically the program is going to be executed. Automatically here we are able to get our required outputs. Similarly, this converter will convert that bytecode into Windows representations. Compilation windows, execution windows. Still we require a converter in the case of Java. Why? Because Java compiler will generate a neutral bytecode. It is not having any operating system representations. So now here, it also be this converter will convert that neutral bytecode into the native code. Native code is like what there? Windows represented code. If we give that Windows represented code to the Windows operating system, where program execution is going to be happen, finally here we are able to get the outputs. As all of you are getting clarity on this point now. But here I have a question. How Sun Microsystems has provided, how Sun Microsystems has provided this conversion mechanism, where the Sun Microsystems has provided conversion mechanism. If you understand it, Sun Microsystems has provided both conversion mechanism and execution. Sun Microsystems has provided both conversion mechanism and execution in a single device. In a single device, Sun Microsystems has provided this conversion mechanism and execution in a single device. In every case, we can understand it now. In a separate device, this conversion and execution both are provided. Right, sir? Now, all of you understand it now? Now, the single device name, what exactly the name of that single device which contains both the conversion and as well as execution, the name of that single device is like what there? JVM. More concentration. This is exactly the meaning of like what there? JVM. Right, sir. Very clear. Now here, this is what there? JVM. Here that conversion and as well as execution both are going on in a single device. Now that device is like what there? JVM, that is provided by Sun Microsystems. Now I'm going to ask one question to all of you. Now try to answer for it now. What is JVM? What is the job of the JVM in Java? What is the job of the JVM in Java? Two responsibilities. What are the two responsibilities? No, first one is what they're translating our neutral bytecode into like what their native code, and the second one is what they're after completion of it executing that neutral code, that bytecode. So translating neutral code into execution, translating neutral code into the native code and executing that native code. They are the two responsibilities of like what their JVM what we are having. Yes, sir. All of you are following the points clearly. But here I have a question now. Now tell me, how many Java programs here we have written? How many Java programs we have written? Only one Java program. See this. How many Java files are available there? Only one Java file. How many times we compiled that Java program? How many times we compiled that Java program? See this. Only one time we compiled the Java program. But how many times we executed our Java program? How many times we have executed our Java program? 4 times we have executed our Java program. Am I right or not? One time we compile Java program, but 4 times we have executed our Java program. Am I right or not? Everybody, put more concentration. One time we compiled our Java program, but 4 times we have executed our Java program. Is my point is clear or not? Okay, fine. When 4 times our program is executed, now tell me 4 times we have used JVM or not? For all 4 times execution we have used JVM or not? But here my question is, in all 4 times execution, the JVM is single JVM or four different JVMs? What JVMs here we have used? Is that single JVM or four different JVMs? That's my question. Is that single JVM or four different JVMs now? At least guess it. The diagram is clear, right? I guess it at least. Is that single JVM or four different JVMs? Alright, it's a confusion. Maybe it's a doubtful, right? Alright, I'm giving clarity to all of you. Observe carefully. Four different JVMs, not single JVM. Four different JVM. Clear answer. It is like what there? Four different JVMs, not single JVM. How sir? How four different JVMs here we are getting there? How is it possible to get that four different JVMs? No. Then, if we come for this point here, I'll give some clarity. Now try to understand the content clearly now. Right, sir. All of you observe carefully. How four different JVMs here we are getting now? Java is a platform independent programming language. Java is a platform independent programming language, but JVM is a platform dependent. JVM is not platform independent. JVM is a platform dependent. Come again. What's the point I said to you? Java programming language is platform independent programming language, but JVM is what there? Platform dependent programming language. How can you say that? How can you say that in the sense? Now the point is what there? All of you observe carefully. Here, what's the point I'm telling to you? Not only JVM, not only JVM, all Java tools which are coming along with the Java software, where JVM is also one of the tool, like JVM, Java compiler, Java C, like a Java profiler, Java document reader, and so on. So many components are available. Not only JVM, all Java tools are platform dependent. When all tools are when all tools are when all Java tools are platform dependent, automatically the total Java software is also be platform dependent. Java programming language is platform independent, but Java software is platform dependent. Understand the difference here? People are getting confusion in general in this point now, but I'm giving clear-cut awareness now. What's the point here I'm telling there? Java programming language is platform independent. Write a Java program that is platform independent. Compile it on one Windows operating system, run it on what there? Different operating systems. We are not getting any problem. We can do that. All of you get my point or not? Platform. Java program is platform independent. I will show. Here anyway I'm using two systems here now. I can do that. How I'm going to do this now? I will compile my Java program on Windows now. Dot class file is generated. I'll keep the dot class file into MacBook. Then in MacBook, without recompilation, directly I can execute it. It's possible. Yes, sir. All of you get my point or not? So the point is what there? Java program is platform independent, but all Java software is totally what there? Platform dependent. Now tell me, if JVM is platform dependent, here what JVM here we are using there? Understand it clearly. Linux based JVM. The JVM is on what there? Linux based JVM. This JVM is what there? Solaris based JVM. This JVM is what there? Mac based JVM. This JVM is what there? Windows based JVM. Yes, sir. All of you get my point or not? So now understand it clearly. Then again, you may have doubt. Sir, how we are getting Mac based JVM, Linux based JVM, Windows based JVM separately? How we are able to get it? How we are able to get it in the sense? Then I will give some clarity. Now try to understand it clearly. I want to download Java software. Now understand it clearly. Java software, Java downloads. I'm going to provide this. What version here? Say for example, Java 8 version for our clarity purpose. You can understand it here. Now try to understand it clearly. I want to download it. RK downloads, no problem. Just let me open it. Now see this one. Here we are able to get Java software's downloadable links. Right, sir. Now here, if you understand it, see this one. The Java software is provided on the basis of what? This is a link. If we click no, Linux based Java software here we are able to get. If we click on this link now, what we are able to get now? Mac based Java software. If we click on these links now, what Java software here we are able to get now? Solaris. If we click on these links now, what we are able to get now? Windows based Java software. But now I'm asking one question there. If Java software is a platform independent, but why these many links and these many operating systems specifications? The one link and one link, then they can say any all operating systems like that they're able to say specify or not. Or just one link and for all operating systems they can specify or not if it is platform independent. But by seeing this content here, what we are understanding, the Java software is what? Java software is dependent on the operating system only we are downloading or not. So it's a dependent on the operating system or not. So Java software is dependent on the operating system. Say for example, if I click on Windows 64 related Java software now, Java software will be downloaded which contains Java compiler, Windows based, JVM, Windows based, Java profiler, Windows based, and Java documentator, Windows based. All the things we are able to get as per what they're Windows based. They will run on Windows operating system only. Say for example, if I download this Java software, then automatically this is what the Linux based Java software, where we are able to get a compiler Linux based, JVM Linux based, profiler Linux based, like this. All Java tools which are as per Linux basis only, they are downloaded. They will sit on the top of the Linux operating system only. Simple example I'm telling there. I downloaded Mac based Java software, but I want to install it on Windows operating system. No, not possible. Not possible. I downloaded Mac based Java software, but I'm trying to keep that on the top of the Windows operating system. I'm trying to install it on the top of the Windows operating system. There it is not possible. Why it is not possible? Java software is what there? Platform dependent. But Java program is what there? Platform independent. Java program is different. Java software is different. Java program is running on the top of the Java software. Understand it here. One more point I'm giving clarity for you. How many Java programs here I have written, sir? Now tell me here. Only one Java program that I compiled on Windows that I'm trying to execute on multiple operating systems, that we understood. But now tell me, how many Java softwares I have used in this total diagram? How many Java softwares I have used in this total diagram? Of course, 5 softwares here I have used on the total diagram. 4 or 5, whatever it may be. Not like single Java software. For compilation, one Java software. Think about it, this is one computer. Now all 4 executions are going on 4 different computers. In 4 different computers, different operating systems. In every operating system, Java software must be available. Then only Java compiler, JVM and all the components we are able to get. Understand the point clearly? So here, in this computer, in this compilation computer, Windows operating system, Windows based Java software I installed. On the top of the Windows based Java software, I compiled my program. Then I'm getting like what there? .class file. Yes, sir. I'll forget my point or not? Clearly. After this, when we come for this one, here what based Java software I installed already? Linux based Java software I installed. In Linux based Java software, Linux JVM, Linux compiler, both are available here. Understand my point or not? Now Linux based JVM is executing our program. Now here, Solaris operating system in this computer, I must install what Java software there? Solaris based Java software here I have to install. There our program is executed as per the Solaris basis. Now here, what operating system, what Java software is required? Mac based Java software here we have to install. Then only we can run the program on what there? Mac. Similarly on Windows. That means program is single, but if you want to experiment whether this Java program is platform dependent or platform independent, multiple systems here we have to take, multiple operating systems we have to take, multiple Java softwares we have to take. Understand my point here? Multiple Java softwares we have to take, but all the operating system respect to Java software we have to install. Then we can execute that single program on multiple operating systems. Then definitely we are able to get output. Yes, sir. All of you are getting clarity on this point now? Nothing else. Then, if you are interested, I will show the same point lively. Lively in the sense what there? I'll prepare my Java program on Windows. Later on I'll switch to what there? This one. There I'm going to execute my program. That I'm able to show. It is not at all big deal. Then easily I can show that point clearly. Is that clear? Okay, fine. That I will do on tomorrow. Just rewind to me. In general, in the introduction part, my people are not understand that Java program. That's why I'm not going to show that. But you're interested, definitely I will show that point here. And tomorrow I'm able to show this content here. Tomorrow I need to give the document for it. No diagram I copied anyway. Document after completion of this experiment we are going to do on both the operating systems. After that, I'm going to talk about the next important difference now. Pointers are required in C and C++, but pointers are not required, not existed in the case of Java. The difference is also big here. We are going to understand. Okay, that's it. That's all for today. I'll meet on tomorrow. Thank you. Thanks a lot.